Hello friends, in this video we are discussing about the derivation of 1D bar elements. In this video we are deriving stiffness factor and shape functions. First of all, we are deriving shape functions by using a simple formula. We already know about what is meant by 1D bar element. It's look like this. Here it is having two nodes. It is number 1 node and second node. Okay. Then the displacement between these two nodes is u1 and u2. Then let us make this as x1, this as x2. x1 and x2 are the coordinates for this node and this node. Now a simple linear equation to solve this nodal displacements. Now what is that simple equation? Let us consider a simple equation. U is equal to a1 plus a2 x. Now here a1 comma a2 are generalized coordinates. Then now writing this equation as 1. Now convert equation 1 into matrix form. It's a simple form that U equal to 1 x in a matrix and a1 a2. By this matrix form or matrix equation, we also get the same equation. We get in equation number 1. Let us consider this as equation number 2. Okay, U is equal to a1 plus a2 is equal to x as a simple equation. Then we already know about what is meant by 1D bar element. x1, x2, u1, u2 are the displacement, x1, x2 are the coordinates. Then the length. L means length of the element or bar element. Okay, then now U equal to 1x a1 a2. Here it is a matrix equation. Okay, then after that we are having two nodes, right? We by using matrix equation and two nodes, we can write as at here the u1 and u2 are written in this equation as u1 u2, that is equal to here 1x here at here x1 and x2 are two coordinates we are assuming. So at here also 1 x1 1 x2, you can write it as like this. Then after that a1 a2 is never changed because both in the equations we are having a1 and a2. Okay, then we only obtain this a1 and a2. So considering a1 a2 on one side, remaining all terms x1 1 x2 whole inverse, because it is converting into in this this is went to in this side, so it is having inverse symbol on the top, and then it is u1 u2. Now we already know what is the inverse formula for 2 into 2 matrices. For 2 into 2 matrices, then 1 by x2 minus x1. x2 minus x1. It is a inverse formula. Det A C transpose by det A mod. Det A. In the same way, we have to transpose this like in this manner. x2 minus x1 minus 1 and 1. Now u1 u2. This is the equation for a1 and a2. Consider this as third equation. Now substitute equation number 3 in equation number 2. Okay, substituting equation number 1 and in equation number 2, we getting this as equation. X. In the whole place of a1 and a2, we are substituting a1 and a2 in that place. So 1 by x2 minus x1, x2 minus x1 minus 1 and u1 u2. Okay, and this equation will be formed. Then we already know about it. For the L, we have to take it as L equal to x2 minus x1. Okay, so in the place of x2 minus x1, we will write as 1 by L. Okay, after that 1 x2 minus x1 minus 1 u1 u2. Okay, for that multiply these two matrices. 1 by L, take it as common, and 1x into x2 minus x1 minus 1 to multiplication between these matrices. Okay, for that 1 into x2 minus x minus x1 plus x. Okay, in this way we have to write matrix multiplication. After the multiplication, we put this L inside the matrix. x2 minus x by L minus x1 plus x by L. Another equation we obtain by sending L inside the matrix. After that u equal to x2 minus x by L minus x1 minus plus x by L u1 u2 is the equation we obtain in equation number 4. I already wrote in the page over, but again I am writing in this page also. Okay, then after that you have to compare this equation number 4 with equation number 4 with u equal to n1 n2 u1 u2. After that n1 and n2, n1 comma n2 are nodal displacements. I already told you in this video we are deriving the nodal displacements. So by here n1 equal to after comparing these two equations, n1 equal to x2 minus x by L and n2 equal to x minus x1 by L. These are the equations we have obtained at the end of the